You should understand what you mean by water technology. See, the water is going to contain three types of impurities: physical impurities, chemical impurities, and biological impurities. Removing all the impurities, that means physical, chemical, and biological impurities, has to be removed out from water that have been used for domestic applications. That is known as water technology. That means removing all these three types of impurities from water and making the water to fit for domestic applications is known as water technology. See, let me explain the two types of hardness of water. See, before starting the types of water, you should understand what you mean by hardness. Okay, hardness is nothing but what a precipitate, a white precipitate have been formed in the water when you add soap water. That is called hardness of water. That means which contains what? Calcium and magnesium. So the water which is containing calcium and magnesium is said to be what? Hard water. The water which is free from calcium and magnesium is said to be what? Soft water. And here when you talk about this hardness of water, again they are of two types. One is temporary hardness and other one is what? Permanent hardness. And temporary hardness means what? They are the bicarbonates of calcium and magnesium salt that can be removed by means of boiling. And they are also called as carbonate hardness or alkaline hardness. And when you go for the other one, permanent hardness, or otherwise it will be non-carbonate hardness or non-alkaline hardness, and they are nothing but what? Chlorides and sulfates of hardness. That means magnesium sulfate, calcium sulfate, magnesium chloride, calcium fluoride, all these fours also are responsible for permanent hardness causing solvent. And this cannot be removed by boiling, so this can be removed by means of lime soda process, ion exchange method, etc. See, always this hardness have been expressed in terms of calcium carbonate equivalent. So why this hardness always expressed in terms of calcium carbonate equivalent means this calcium carbonate molecular weight is 100 and its equivalent weight is 50. So it is a whole number value. So easy for the calculation. And not only that, and this calcium carbonate is highly easily precipitated salt. So that is the reason why this hardness always expressed in terms of this CaCO3 equivalent. And here this total hardness is nothing but sum of temporary hardness and permanent hardness. Students, please understand, you should know the molecular weight of each and every salt. For example, magnesium bicarbonate 146 the molecular weight. How will you calculate the molecular weight? By adding the atomic weights. See, for example, in this magnesium bicarbonate salt, we know the atomic weight of magnesium, hydrogen, carbon and oxygen. Or add all the atomic weights, you will be getting the molecular weight. Okay, then calcium bicarbonate molecular weight is 162 and magnesium chloride 95, magnesium sulfate 120 and calcium fluoride 111, calcium sulfate 136, magnesium nitrate 148, magnesium carbonate 85. It's the molecular. And units of hardness. So there are 4 units of hardness we are going to discuss here. So one is what? ppm, parts per million. The second one is milligram per liter. And then the third one is degree Clark. And the fourth one is what? Degree French. So these are the what? 4 units of hardness. And how are they related with each other? 1 ppm is equal to 1 milligram per liter, which is equal to 0.07 degree Clark, which is equal to 0.1 degree of French. And how will you test the hardness? Actually, I told you in the starting itself, when you spray some soap solution into the hard water will not produce any lather. But the same when you put the this soap solution in the soft water, it produces what? Lather. It produces the lots of bubbles. So by seeing the bubbles, actually we can able to confirm which is hard water and which is soft water. So hard water do not produce any lather with soap solution. Instead, it forms a white insoluble precipitate known as scum. And if you go for soft water, when it is sprayed with the soap solution, it forms lather. It forms lot and lot of bubbles, but it do not produce scum. And there is another test here. You take hard water and soft water. Okay, in the hard water, when you add 5 ml of ammonia buffer and when you add 2 to 3 drops of EBT indicator, a wine red color is obtained. Now it is the hard water. Instead, if you are getting steel blue color, it shows the presence of soft water. And next, The role and significance of following ion exchanges in water treatment. There are so many ion exchanges. That means it exchanges its ions with calcium and magnesium. So in that, we are going to discuss four important ion exchanges. One is zeolites. The next one is marylonite, clay, soil, humus. So these are the four important pictures, okay, which is going to be the materials which is a very good ion exchanges. Thank you.